Good morning, everyone. Welcome to this lecture number 7 on data organization and file management in Stata. I'm very delighted to be hosting this lecture today, especially because you are on the phase where you're currently wrapping up with your final report. So I think that will be a very useful lecture, so you guys can use the knowledge that you will acquire to polish your reports and hopefully make a better job. So I'm Swazik Alice Wangson. I gave the lecture number 3 on descriptive statistics, and I'm currently a PhD full at Merit. So the outline of this lecture: first of all, I will talk about file structure and data management, taking stock on the TAIER protocol, TAIER, which stands for Teaching Integrating Empirical Research, from Haverford College in the US. And secondly, we're going to talk about the best practice for code management, most importantly, how you can make your do file much more readable and ease the sharing process of your codes with your instructor. And lastly, I'm going to talk about master do file, how you can put the different do file that you use for importing your data, for cleaning up your data, for doing descriptive statistics and inferential statistics like hypothesis testing or some regression. So how you can run all those do file into one do file. Okay, so why should we really care about file structure and data management? Why are we here talking about that? Why is that important? So first of all, for yourself, right? So you have to be able to remember, reconstitute and easily reproduce your own work, because even a year later your mind can play you some trick and you won't be able to clearly recall all the different steps that you use to produce your report, or why have you done this specific strategy to clean up or to analyze your data. So you should be able to have a very clear or a very strong file structure to be able to remember even a year later what you did. And I really like this quote from Philip Stark, who is at UC Berkeley Department of Statistics, who really used to say that reproducibility is just collaboration with people you don't know, including yourself, next week, right? So as I said, our mind can easily play us some tricks, so it's always important that you document all the different steps that you did to be able to produce any scientific report, right? And secondly, we care about file structure and data management because it helps you to conduct your work much more efficiently, right? Like if all of your different files are well structured, you have this ease of actually be much more efficient in the way you're doing your work. So that's one of the first reasons. You're doing it first because of yourself, but you're also doing it because of the social science community. And I really have to highlight the fact that over the past decade, transparency and reproducibility in the social science has become the norm. So input of all scientific reports should be well documented and organized to allow your instructor or other researchers, so it can be your classmates or it can be any other people of the scientific community who might be interested in reading your report. They have to be able to easily check the reliability of your work and replicate your results. So that's very important, and for that you should be able to build a very strong data analysis workflow, right? From the raw data file to the clean data set, and then for the result that you had for public policy decision. And here I'm just trying to show you the importance of reproducibility and replicability in social sciences by underlining the fact that there has been a lot of academic research misconduct in economics and especially in public policy over the past decade. And you potentially heard about, for those who are very interested in public policy analysis and impact evaluation, there has been what has been tags in the academic literature the warm war, especially because there has been some researchers that have tried to replicate one of the paper of Ted Miguel, and then there was some debate about not finding exactly the same result. But most importantly, there has been the Michael Lacour scandal, right? Lacour was actually a PhD student, and then he was working with Donald Green, who is a professor at Columbia University, and then he wrote a paper. They wrote a paper on attitude towards same-sex marriage, and the paper was retracted, even though it was already published in a very well-known scientific journal called Science. So just because people have tried to replicate the same work, they were not able to. And it's not just this paper. There have been a lot of cases, right? I'm also trying to cite the work of Martin Feldstein on social security and private savings, for instance, where people have tried to use what they share as their do file and try to replicate using the raw data set, and they weren't able to have the result that they had on the paper, right? So it's very important for you to understand that there is a stake in the way you're doing, because you're jump starting your career in the scientific world. So it's very important for you to know how you structure your file, how it's important for other people to check the reliability of the result that you have, because it's served for the policy decision later on. So it's important for you to know how to structure your file. And apart from that, even in social psychology, there has been a very famous social science psychologist, and actually he was retracted. He has more than 10 journals that has been found to be flawed, and he just said he has failed as a scientist, right? He recognized the fact that he fabricated his own data set, and the result that he got wasn't really reliable. So you guys should understand that it's important for your career, for your future career, especially for you guys who would like to do to further your study into research. It's important to clearly to be able to share your data, and for other researchers to find out the same result that you got if they take your raw data and do the same analysis that you did, right? And that require you to have a strong, or to build a strong reproducible statistical workflow that we are going to talk about in the second part of this lecture.